Today we did angles of depression and elevation for trig. Okay, we said that an angle of elevation of F from N, for example, is if you have a person standing here and they're looking up at a flagpole F, then this is the angle of elevation. We said that the angle of depression of N from F is if they're standing at F and they're looking down, then that is the angle of depression. Okay, we did an example, which you can see in the previous video, and I am going to do another example from exercise 6 on page 78. This is question B. The question reads that an architectural design of the front of a house is given below. The length of the house is to be 10 meters and exterior stairway leading to the roof is to form an angle of elevation of 30 degrees with the ground level. Alright, the slanted part of the roof must be 7 meters in length. And I'm skipping over it pretty much because it's all given on the sketch. I'm just comparing everything that I read to the sketch to make sure it's there before I continue. Okay, calculate the height of the vertical wall. Okay, so they want the vertical wall DE. All right, and calculate the size of theta, the angle of elevation of the top of the roof A from the ceiling BCD. All right, so they want the angle theta. And calculate this. Calculate the length of the beam AC. Right. So here is our sketch, and we can divide this into multiple parts. Okay, but the first part that we want is DE. Okay, that's the first question. So I'm going to redraw this triangle. This triangle has 10 meters here at the bottom. Now, I'd be very surprised if the house is designed not to have a right angle there. So it probably does. It almost definitely does. Okay. So that's 90 degrees. And then this angle is 30 degrees. Okay. So we're working with 30 degrees over here. We want DE. Okay, we want to know what that is. All right, so we're working with this angle over here, and this will then be opposite. This will then be adjacent, and this will be the hypotenuse. Okay, so we have the adjacent, we want the opposite, so we're going to work with tan. Okay, tan of theta, or rather, tan of 30 degrees is equal to opposite, which is DE, over adjacent, which is 10. We're going to multiply with 10 on both sides to get rid of the denominator 10 because we want DE alone. So these are going to cancel out. That's going to give me 10 tan of 30 degrees equal to DE. Okay, and we didn't read this part, but the question does say round off to 1 decimal place. So let's say tan 30 times 10, and that's going to give us 5,8. All right, so DE is 5,773, blah, blah, blah. Rounded off to 1 decimal place is 5,8 meters. All right. So let's fill that into our sketch, 5,8 meters. Question 1 done. All right, now we want to calculate the size of theta, the angle of elevation of the top of the roof, A. All right, so that's the top of the roof. We want angle theta from the ceiling. Okay. So over here, the first thing that I do want to do is just double check this. This is obviously parallel to that. So this is going to be 30 degrees. This is 90. I'm just filling in everything that I can see for now until I figure out how we're going to do this question. Okay, because sometimes you don't immediately see what's going to happen. Over here, we're obviously going to have 60. That's going to be 60. And I'm going to tell you what, this side, this angle is going to be equal to that angle over there. Oh, okay. So I've obviously spotted how we're going to do this question, okay? So this is, I'm just trying to keep the page out of the way. This is 10 meters. And this is 10 meters. Okay. Now this is 10 meters in total. But that means that this is 5 and 5 meters. So that's 5 meters. And that's 5 meters. Okay. So I'm going to work in this triangle over here, A, B, C, because I have 7 meters and 5 meters over there. All right. So this was question 1. This is question 2, and I'm going to redraw that triangle over here. This was 7 meters. This is 5 meters, and this is theta. Okay. And I'm going to tell my teacher which one I'm working on in triangle ABC. This is A, B, and C. All right. So in terms of this angle, that is opposite, that is adjacent, and that is hypotenuse. Okay. So we have adjacent and hypotenuse. So we want to work with cosine. Cosine of theta is adjacent, which is 5 over hypotenuse, which is 7. That means that the inverse of cosine of 5 over 7 is going to give us the angle theta. Okay, so we're going to press shift cosine of 5 over 7, and that's going to be 44,41. Okay. So theta is 44,41 blah 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 degrees, and we're going to round that off to 1 decimal place, 44,4 degrees. Perfect. All right, so sometimes you just need to take a moment to look at it. That's 44,4 degrees, which is also that. All right, so we have question 2 done. Then they want you to calculate the length of AC. All right. So I'm going to be working in this triangle again over here. All right, so there. I'm just redrawing it a bit bigger because in the previous question I believe that I drew it too small. Okay, this was 7, that was 5, this was 44,4 degrees. Okay, question 3. Now, I want to rely on my previous questions as little as possible. You can, of course, use the previous question and use a trig ratio for this. But what I'm going to do is I'm going to do Pythagoras. This is the hypotenuse, this is the adjacent, and this is the opposite. Okay? You can use your trig ratios for this. Okay, but I'm going to use Pythagoras. Pythagoras says that the hypotenuse squared is equal to the adjacent side squared plus the remaining side squared, the opposite side squared. So this gives us 49 equal to 25 plus AC squared. You're going to say 49 minus 25, that's 24. Equal to AC squared, and you're going to take the square root on both sides, and because we're working with lengths, this is definitely going to be positive, so it's going to be AC equal to 2 times the square root of 6, which is 4,89 blah blah blah, rounds off to 4,9 meters. Done. All right, I hope that helped.